Okay, where our last rocket, our projectile review question left off, it looked like this. Well, I cleaned that up a little bit, and we'll call this projectile review part 2. This is one of those, what most of you would consider a little bit of a harder question. Oh, come on, Sharpie, right. Obviously, I think my picture looks better, so we will call this video projectile review number 2, or I wonder if Lebron can handle this. Anyway, moving on. So this is kind of like the basketball player type of question, or kicking a field goal, except it gave you X, it gave you height. It didn't give you this VO, which is harder of all the projectile questions. This is it. All right. But go back to what you've been taught to do. Look at what's in front of you and think about what you've been taught to do. First thing I've always told you, find VOX, find VOY. Now in this case, I can't find VOX, but what I can do is I'll just write the equation for VOX down. VOX is equal to VO cosine theta. So I can write the equation. And the same thing, try to find VOY. Yes, I know I can't find VOY, but I can write the equation. VOY equals VO sine theta. So I can write my equations down. So check, I've got 2 equations. Now, I've got an X, and now I can think, well, another equation. What is the only equation good for the X dimension of a projectile? How many times can I tap my finger if I go, oh, no, no, no. Anyway, so the only equation any good in the X is X equals VOX T. Now, let's not stop writing equations yet. I'm going to write one more equation. It gave me a Y. Well, I've only got 2 equations with a Y in there. The second and the third kinematic equation. Well, the third equation, though, doesn't have time, and that time is what ties all this together. So since I've got a Y, I'm going to write Y equals VOYT plus 1/2 AT squared down. And now I want to do something. I've written down every equation that's got anything to do with the projectile. So what am I going to do now? Well, now's actually where the fun starts. Really, the physics in this problem is over. We've written down every possible equation. We're going to try and find that velocity initial. I'm going to go ahead and do something. I'm going to spread this out a little bit so that it's less compacted over here. But I'm going to start putting all these equations together. The easiest thing I can do is replacing VOX. VOX is VO cosine theta. So I can rewrite my X equation as X equals, instead of VOX, I can go VO cosine theta is equal to VO cosine theta t. So all I did was substitute in for that VOX. Well, let's go over here now to the Y equation. Y is equal to VOY. Well, instead of VOY, what is VOY? It's VO sine theta. So I can substitute again, and into this spot write VO sine theta t plus 1/2 AT squared. Well, cool. So now I've taken 4 equations, and I'm down to 2 equations. I want you to look at something. How many unknowns do I have left? I know X, VO cosine theta t. I know theta. Theta was 40 degrees, so I've got that, cosine of 40. I've got Y. I know sine of 40. I know half of negative 9.8. It's going to be negative 4.9. I've got everything right now. I've got everything in this problem except VO and T. And I've got 2 equations and 2 unknowns. So mathematically, I'm in really good shape right now. So now what you've got to do is this, thinking-wise. 2 equations, 2 unknowns. You've got to solve one of these equations for either VO or T and plug it into the other. Well, when you're going to do this, pick the simplest equation to try and solve. Which one of these 2 is the easier equation? And then this one. This is by far the easiest equation. Now you've got a choice. You can solve this one for VO and substitute for VO, or you can solve it for T and substitute for T. Well, let's just look at both ways. So let's solve this equation for VO first. If I want VO, What's the opposite of multiplying by cosine theta and the opposite of multiplying by t? Divide both sides by cosine theta t. So I can have x over cosine theta t equals VO. What if I wanted to solve it for t and try that approach? Well, I would have x over VO cosine theta for t. So I've got two ways of doing it. Both are exactly, right. The problem actually wants VO, which means reality of it is I should plug this t back in, and then that way all I'm left with is VO. But here's the thing. For most of you, your math sometimes is not what it should be. When you plug in this t, this thing's about to become, in redneck language, what we'd call a Buick. When you plug this t in, it won't be bad here, but oh my goodness, right here, you're going to have to plug it in for this squared variable, and you're going to have x squared VO squared cosine squared theta, and I'm happy to do that at the end of this video. But for right now, I'm going to be honest, the math is a whole lot easier to plug in for VO. So what I'm going to do is I'm going to take this VO equation, because the math is just easier, and I'm going to substitute it right there for that VO. So now let's do that. Y is equal to, and in place of VO, I'm going to write this x cosine theta t. X over cosine theta t times sine theta t plus 1/2 AT squared. Now, take a look at this. We've got a couple things going on here. One, sine over cosine. We're about to end up with sine over cosine. Because what we've got here is this. I would normally not write this out to this degree. Matter of fact, I'm going to do it on a scratch sheet of paper. I hate to wreck this good sheet of paper. See if I can get another sheet of paper here. But usually what I would do is this. You've got x. Let's do an up-close math look here. What does this mean? What does it mean when you multiply that? It means you've got x sine of theta t over cosine of theta t. Well, here's the thing. Sine theta over cosine theta is tangent theta. T over t, well, t over t cancels. So we're just left with x tangent theta. Now somebody asked me the other day, can I get this problem right by just leaving sine and cosine? Oh, yeah, for this problem you could. It gave you an angle. What if the problem didn't give you an angle? If the problem didn't give you an angle, then you couldn't have these two variables like this. You would have to reduce it to tangent theta. Plus, sine over cosine as tangent needs to be stuck in your head 100%. So it's not even a question what we're going to do. We're going to change it to a tangent. So this problem becomes y equals, now look, t's cancel, and we get x sine over cosine. So y equals x tangent theta plus 1/2 AT squared. And we've only got one unknown left in this. We know that y was 5, so this is 5 equals x is 20. Tangent of 40. 1/2 of negative 9.8 is negative 4.9 t squared. We are so ready to get this done. So we're going to subtract 20 tangent 40 from both sides. So we're going to end up with 5 minus 20 tangent 40, negative 11. So we've got negative, come on Sharpie, 11.78 equals negative 4.9 t squared. So divide by negative 4.9. Now, remember, the negatives are going to cancel, so that's not a problem. But remember, you've solved for a square, so take a square root of this answer, and I've got 1.55 seconds. And now you're saying, fantastic, look at how incredible I am. It's just this problem asks you to find VO, not T. But the thing is, once we have time, it's very easy to go back to here and find VO. So we know that VO was equal to x over cosine theta t. So this would end up being 20. 20 was my x value, over cosine of 40, the angle, times 1.55 seconds. And now we have that VO. Oh, it's a little bit of work, but it's not that bad. Let's go with 20. I got 20 divided by cosine 40 times 1.55. And I've got 16.8 meters per second for our final answer to this question. Now, this is where this problem's done, and if you're just looking for a way to do it, look no further. This problem is a solved problem. I, however, would like to take one additional step in this problem. What happens if you're not a coward? What happens if you're like, hey, Turdferg 67, I need to write a video explaining that one day. But anyway, hey, Mr. Cole, why don't you show some charisma? Why don't you plug that in? Oh, is that a challenge? Is that a challenge? Because I won't back down. I won't back down. Isn't that a movie? Never Back Down. Anyway, let's break this out right here. Let's go back to where we had those two. And again, you can quit now if you're scared. If you ain't scared, then you can keep watching. Are you still watching, or did you just click it off? Nope. Somebody's still there. I can hear you breathing. That was creepy, wasn't it? Sorry. I'm thinking of small talk while I write all this down. All right. So let's go. So you think you want to be a big star. What's the math going to look like here? Well, let's go through it. I'll try and be slower and neater. I'm going to plug this in for time. I'm going to substitute. So this is going to be VO sine theta times, so I'm going to substitute for that t, x over VO cosine theta. Cool. Now, plus 1/2 a, check this. For that t, I've got to plug it in again. X over VO cosine theta. I don't know why I did these parentheses in red and the others. I don't know. Square. This problem is done. It is purely now, can you do the math on this to reduce? Once again, VO over VO. VO over VO, what's going to happen? Your VOs cancel. You've got sine over cosine. You know this. You've learned it. Y would be equal to sine over cosine, which would be tangent theta times x. Well, this part looks the exact same. This is where she's about to get a little crazy over here. You see, this becomes now plus 1/2 a times, check this out, this is x squared, I don't know why I wrote the x so big, over square all this. The VO, square. The cosine, and if you don't know how to write cosine square, there's how you write cosine square. Square the cosine term. And we're looking for that VO, and you could try and put in numbers right now, I guess, if you wanted. I'm going to do one more step. I'm going to clean that up. Y equals tangent theta x, and this becomes ax squared. I want this to be a little more streamlined. This would be ax squared over 2VO squared cosine square theta. Now, this thing is done we could try and formally solve it for VO. Now, that would be rather cumbersome. Or we could plug in numbers right now. I have no idea which way I would pursue this. If I would do more algebra, if I would solve it for numbers. We'll do algebra. Y minus tangent theta x. Anybody can plug in numbers. But this is about being a pimp of math. If I'm looking for VO times both sides by VO square, which would cancel it over here. Oh, I'm going to need more paper. So I end up with VO square times y minus tangent theta x equals ax square over 2 cosine square theta. Goodness. Now, divide both sides by y minus tangent theta x. I'm running out of room. VO square would be equal to, check this thing out, ax square on top. A is negative 9.8. And on bottom we're going to have y minus tangent theta x times 2 cosine square theta. And then if you wanted VO, take the square root of this entire thing. So what about, and believe it or not, I have used up every sheet of paper in my possession at this very moment. I'm going to have to raid my printer. Bear with me, this video is getting really long, but I don't know if anybody's still watching. Did you have the courage? Do you have the courage? We can make you faster. We can make you stronger. That's actually a very old TV reference. But anyway, let's go to right here. Plug in our numbers. So VO square would be equal to negative 9.8 times x, which was 20, square over y. Y was 5 minus tangent 40 times the 20. Boom, all that in the parenthesis, times 2. The cosine square is the thing I thought might get some of you. Write it like this. Cosine 40 square. That's how you treat your squared cosine if you don't understand that. Oh my goodness, how did I end up with this? Top, negative 9.8 times 20 square. So the top is negative 3920. Let's do this tangent 40, 20. 20 tangent 40. So that's 16.7. So 5 minus that would be negative 11.78. 2 times, watch how I do this. 2 times cosine 40 double parenthesis, because I want to square the cosine of 40. 2 times the cosine of 40 squared, and that's 1.17. So now this would becomes, I'm going to put it in, negative 3920. If you got a really nice calculator, why not use it? Negative 11.78 times 1.17. 284. I've done this problem wrong. Oh, no, I haven't. Unit would be square, square. Here's the thing. Remember, this is VO square, which means you still need to take a radical to find VO. Radical of that answer is 16.8. In the midst of all this, I don't even know if I know where my first answer was. And what did we get? 16.8. I hope this gives you an appreciation. If you take a look, here is that whole entire solution. I hope this gives you a little appreciation about when I said the math was easier to solve for VO and substitute. I hope this gives you that appreciation now. Again, I don't know if anybody watched this, but it was good for you. At least watch the first 10 minutes. But anyway, happy WWOO I don't know. Maybe this could be like, oh, it's a foot race. I don't know. I'm out and I'm tired. So y'all have a good one, and I'll talk to you later. Bye.